ladies and gentlemen. So today we're going to be starting day 6 of our word problems. We're going to be looking at distance problems today. And last year in science you learned that the distance formula is D equals RT. D stands for your distance. R is for rate. And T is for time. The rate in this case actually means the speed at which it's traveling. Okay, so when we say R, we're really meaning the speed. We're going to be looking at two different types of problems. The first one's called average speed, where one object goes a distance at one rate, then continues at a different. And then two traveling objects, where they're traveling at different rates, and they're either going towards or away from each other. All right, we're going to start off with the average speed. So the average speed formula, so when we're using our D equals RT, and we have to know that this is total distance and total time. And then your R is going to be the average of those. All right, so let's take a look and see. So we have Travis and Tony skate in the park. It took them 40 minutes to skate 5 miles. The return trip took them 30 minutes. What was their average speed for the entire trip to the nearest mile per hour? So we have to make sure that we're matching up units as well. So identify the information. So we know that, that going there took 40 minutes and it was 5 miles. Home, or coming back, returning, however you'd like to say that, took 30 minutes. Now, my guess is, because they didn't tell us anything else, is that it's still the same 5 miles, right? So that's the information. So we're actually going to now take this and find any information that is needed. We don't really have anything that's not needed. So plug into our formula. So our formula is D equals rate times time. But I need, again, totals here. So you know what, actually I'll fill that in here. So my total distance is 10 miles. And my total time is 70 minutes. Here's the problem though, is that I need it to be in hours. So what I'm going to do is I'm just going to take this and write it over 60. That turns it into hours, and hopefully you know that there's 60 minutes in an hour. So when I put it in, I'm going to use this 10, and I'm going to use the 70 over 60. You could divide it out, but it's going to give you this repeating decimal, so I think it's personally easier to keep it as a fraction. All right, so let's put it in. So total distance, 10. We're looking for the rate. Total time is 70 over 60. And I'm putting it in parentheses because it's a fraction. Right, that's from our first part. So to finish getting R by itself, this is a fraction, so I have to multiply by the reciprocal. So I'm going to do that in a different color just to show you. So we're going to multiply by 60 over 70. Which is going to give me a rate of 8. If you do this on your calculator, it's going to give you 8 4/7. It asked for it, if you remember way up here, it wanted it to the nearest mile. So this is going to round up to 9 mph, miles per hour. All right, so a lot of reading and making sure that you are looking carefully. Okay, next one. Austin ran 2.5 miles in 16 minutes and then jogged 1 mile in 10 minutes. What was his average speed? Again, nearest mile per hour. So my total distance is my 2.5 plus my 1, so 3.5 miles. Total time, excuse me, we have 16 minutes and 10 minutes, so 26 minutes. If I want to write that as an hour, it's 26 out of 60, because there's 60 minutes in an hour. All right, so my formula, D equals RT. Distance was 3.5. We're looking for R. T is 26 out of 60. Because again, they wanted it as miles per hour. So So I'm going to multiply by its reciprocal, which is 60 over 26. And when I did that on my calculator, I got rounded already 8 miles per hour. Because again, it wanted it rounded. All right, formula for the next kind. So this is a little bit different because what we're looking at is for total distance, right? So the total distance is the distance of object A plus the distance of B has to give you the total. But they're not going to just give it to you as the total distance. They're not going to say A went this far, B went this far, what's the total? Because that's, you know, like a first grade problem. What they're going to give you is they're going to give you the rate and time of A. They're going to give you the rate and time of B, or one or two of those, and that's going to be our total distance. All right, well, let's see how that works. So two trains are 550 miles apart, heading toward each other on parallel tracks. Train A is traveling east at 35 miles per hour. Train B is traveling west at 45 miles per hour. So you basically have one coming this way, one coming this way, and we want to know how long is it going to take them, right? So we also know how far apart they are, though. So they're starting at 550 miles apart. That's their total distance. So this is total distance. We're looking for the time, right? When will the trains pass each other? So we're looking for how much time. So let t equal time. Well, we need the rate of train A. The rate of train A is 35 times the time. I need plus the rate of train B, 45 times the time, equals the total distance of 550 miles. This is now combine your like terms. Oops, how about 80? Sorry. Okay, so 80t is going to equal 550 divided by 80. So 6.875 hours. There is a decimal point there. Now, if it had asked, this is how long it's going to take them, if they had told us what time they started, then I'd have to add the 6.875 hours to it, but they didn't ask that. All right, next one. Two cyclists began traveling in opposite directions on a circular bike path that is 5 miles long. So we have this, here's your path. We know the total's 5 miles. And we have one person going one direction. Ooh, that was pretty bad. And we have another person going another direction. So here's the rate for the first one. Here's the rate for the second. And we want to know how many minutes will it be. Okay, we need to know how many minutes. So I'm going to find it as hours, and then I'm going to change it into minutes, because I think that's a little bit easier. So we're going to let t equal time. We know the total distance is 5. We know that the first cyclist is going 12 miles an hour, so rate times time, plus the second, 18 times time. So that's going to give me 30t equals 5. Divide by your 30. I'm going to keep this as a fraction, which is 1/6. If you did it on your calculator, it's going to be 0.16 and the 6 repeats. But this is hours. So to find time or minutes, just like before, if I knew hours or minutes and I needed to find hours, I had to divide by 60. Here I'm going to multiply by 60. So 10 minutes. All right, so if you can keep the rate and time and you need to label things, you shouldn't have any problems with this. But if you do, you know to come for help. Have a good night.